Thank you very much, Jim. It's a pleasure to have you with us on the Edison Awards Meet the Innovators Forum. I want to begin with the issue of plastics, if we could. Understanding how to turn the plastics economy into a circular economy is a big target of innovation right now. I know at Dow you're focused on this quite a bit. Before we get into some of the solutions, help us understand the problem. Give us a sense of how much plastic that we use is sort of on a one-way trip right now.
Well, plastics, as you know, are an indispensable part of the world's consumer demand, and it's vital for us to continue to produce them to really enable a zero carbon future. And they're used widely because they're lighter weight and they're stronger, and they have a lower carbon footprint than any of the alternatives. Sustainability has been a big reason for growth. What's the issue is today, a lot of plastics and a lot of other things that we use as well, we just dispose of. And today, when we dispose of them, they go into a landfill. Or in a country like a region like Southeast Asia, a country like India, they probably don't go to a landfill. They probably go to an open dump, and then they eventually end up in our oceans. And we all agree that plastic waste or plastics in the environment is a problem. It's estimated today that about $80 to $120 billion worth of plastics make it out into the environment. And that could be a raw material source for recycled goods and another life for plastics. And so that's what we're trying to do, from circular design, designing materials so that they can be recycled, to collection and actually recycling them, and then putting them into another life, another use, and potentially following the circle all the way around again.
It seems to be one of the keys when you look at solutions, whatever they may be, is you really have to have a very targeted regional approach. If you have fantastic recycling facilities in the United States or Europe, but the problem is in Southeast Asia, you may not be going after it very effectively.
It's absolutely right. And as you try to solve the problem, you begin to realize how local it is. Most waste is managed at a municipal basis. So you're dealing with townships or counties to deal with the waste management issue. You have many different waste management companies in the supply chain, and policy impacts a lot whether waste gets collected, whether recycling gets collected and reused, or whether it just goes to landfill. In many cases, the growth in both population, the growth in middle class, and just the numbers in Asia have meant that waste management couldn't keep up with the demand for products. And plastics are used largely to keep our food safer, to deliver fresh drinking water, to help in medicine and medical applications. And so when you think about it, you're not going to do without these as the population grows. So right now, we're having to rethink the entire value chain and rethink that linear economy and how we bring it back around. And the good news is there is a lot of money in the capital system moving into ESG investments, and there's a demand for recycled material being created by the consumer brands today that did not exist even 5 or 10 years ago. You're talking about major brand owners committing to use recycled materials in their packaging and in their next generation packaging as well. And that's going to really help close the loop, get that supply demand balance right, and get the policy right. And I think we can close it.
Let's talk a little bit about consumer demand. How much of this is being driven by that? People have much greater awareness now about this problem, but there's a lot of good reasons to make the plastics economy circular besides just consumer demand. Give us the full mix of what's driving this momentum in this direction.
The big driving force is how do we make the world better? So whether we're talking about climate change, whether talking about plastic waste, or we're talking about social injustices, everybody's driving to make the world better. And that's putting pressure on everybody that makes goods or delivers services to do things in a different way, to do things in a better way. And so that pressure or that need or want is really driving the increase in demand. The one thing that is true that people have to remember is we are where we are today because these are very efficient ways to do things. So there's a cost for not making for having a linear economy, there's a cost in terms of plastic waste. For a circular economy, there's a cost as well. And so there's got to be some infrastructure developed, and we've got to really change the way we do things. And I think that's true, whether you're talking about climate, you're talking about energy, you're talking about automobiles, you're talking about plastics.
How much do you think the problem is about the kinds of plastics that are created, whether it's their use, single-use plastic? There's a lot of single-use plastics out there, but in many cases, these plastics, because of the wonders of chemistry, you can make them so specifically tailored to a product that they become very complex, long polymer chains, which actually makes it a little harder at the other end to do the recycling. Is Dow kind of rethinking how plastics are produced in the first place to make them ultimately more easily recyclable later?
Well, innovation and sustainability are going to go hand in hand, I think, as we move forward. Sustainability will be a part of almost every innovation that we do, whether it's process technology or product technology. I don't think you will change the nature of the plastics that we make from being longer chain materials, but we're going to have to open up other methods of recycling. So today, if you wanted to, the easiest thing to recycle would be through mechanical recycling. So maybe think about a soft drink bottle or a bottle for bottled water made out of PET. That's a fairly easy recycling program. And you use mechanical recycling. You chop that up, you melt it, and then you turn it back into a product. That's a low energy way and the lowest CO2 way to recycle. But advanced recycling brings in angles like pyrolysis and gasification. So I can actually turn that plastic and those more complicated plastics back into a chemical monomer that can be fed into a plastics plant again. It's a little bit more energy intensive than mechanical recycling, but it's a lot less energy intensive than actually making plastics in the first place, especially if you go all the way back to the production of oil and natural gas. And so that's what we need to do, is open that up. And as we open that up, we'll allow those types of recycling. That will increase the amount that we can recycle. And as I said, the demand is there from the consumers. And you'll have a very good way to make progress on that, maybe as much as 2/3 of the material that won't be able to be mechanically recycled.
Tell us why so little, especially in this country, is currently recycled. Is it consumers don't separate things properly? Is it because of the complicated nature of plastics? The fact that every aluminum can is like every other aluminum can. Plastics are a much more complicated thing. Or are there some other factors?
I think with any material with recycling, it's like if you think about e-commerce, the most difficult thing is to deliver the product that last mile to the customer. It's the most expensive part of the journey, is that last mile of delivery from that last distribution hub to the home. Well, the most expensive part of recycling has been gathering up all the waste and bringing it back to a facility to recycle it. We do it today with metals, but you think about the places that we do it. We might offer a deposit on a metal can. You bring it back, you get your deposit back, and then at the grocery store, the supermarket, you've got a pretty good source of raw material. In Michigan, we've been recycling bottles for a long time. We've had a 10-cent deposit law on soft drink bottles and other bottles. And so when you bring them back, you get the 10 cents back. And then the retailer has a nice source of raw material for recycling. In some cases, we don't give the consumer the option of recycling. So in many places, if you have recycling at curbside, you can put a milk jug or a bottle in there, but you can't put plastic films in there. And plastic films are actually recyclable. You can take them to the store and put them in a bin, and then they get recycled, but they don't get collected at curbside. So we have to make that more economical. And then the other reality is it's very inexpensive to landfill material. And so when you look at landfills, we have in this country probably enough landfill area for another 100 years. But if landfill costs $100 a ton, it's not very, there's not much incentive to recycle that material. So you've got to look at policies that affect whether people are going to recycle or not. And then obviously you have to transport that material, and there you burn fuel and you generate CO2 as well. So it's been lower CO2 and lower cost to make virgin material than it has been to recycle it. But if we want to change and we don't want the waste to go into the oceans, we've got to invest in infrastructure. We've got to close that loop and bring that supply back because the demand is there.
And of course, where the problem is more acute, that equation is very different. The landfill space is not quite there. So that makes it more acute. It leaks out of landfills in the places where there's a problem. I think that's probably an important point for folks to understand.
I would say that's a good and a bad thing. It's bad that it ends up in an open dump, sometimes as much as 100 yards away from a beach. But it's good in that you can start fresh and you can build the type of waste management facility that we're building even in the United States today, these advanced municipal waste and recycling facilities that do everything in one place. They sort waste, they take waste that could be landfilled. Maybe it can be used to generate power, and they generate power, they power the facility, they sell back to the community, they recycle. They do everything at once. So you're not fighting an existing infrastructure, you're actually creating an infrastructure that doesn't exist. So in those nations, that isn't a bad thing. They're going to have to invest infrastructure anyway. Here, we're fighting an existing ecosystem, and we're trying to change that entire ecosystem.
Tell us about some of the innovations Dow is focused on this front in more advanced forms of plastics recycling that take you beyond the mechanical recycling.
Well, it really starts with design. So our first intention is to design for circularity. And as you know, in some of the food packaging, it looks like simple packaging to somebody that's walking through a store, but what they don't realize is that a meat or a cheese or a stand-up pouch or an aseptic package like a drink box are very complicated structures, and they're hard to recycle. So how do you rethink those and be able to design them in a way that they're designed for recyclability? A great example with a partner at Kellogg's, we took a granola package for their Bare Naked granola, and instead of it being a multi-layered pouch that was hard to recycle, we could go back to the chemistry and go back to the catalyst and come up with a polymer that delivered all the properties they needed that could easily be recycled. We're doing that now in many countries, but China and the US specifically, for things like the pouch that your dishwasher detergent tabs might come in. We're also looking at how do we take recycled material and make them into something different. For years, we've worked with partners who make architectural plastic wood decking. And so you take recycled plastics, but you have to compound them with other materials to make a product that has many, many years of useful life. So if you apply that same thought process to, for example, making a building block for a building, instead of making a concrete block, you can make one that's modified with concrete and recycled plastics in it. It's much stronger and it lasts longer, and you've got a way to make buildings lower cost. You can also make that block completely out of recycled plastics, interlocking blocks that can go together and easy to work on. And we've made plenty of them to where we've got schools all over Latin America where we could demonstrate how you can make a school from just a concrete slab and those blocks. We're looking at how do you incorporate it into roads. One of the problems with road structures is potholes and the way they decay. But if you incorporate a little bit of recycled plastics and displace that bitumen and some other materials into the additives, you can make roads that last longer, don't develop as many potholes. That's a great extension of maintenance dollars for states and for transportation departments. We're looking at obviously how to replace the virgin materials today. So if you were to go buy something that's in a collation shrink package, today we sell a product that has as much as 50% recycled material in that collation shrink. So we have literally hundreds of collaborations going on right now to try to develop more demand for recycled materials and recycled materials that have the qualities of virgin material. And whether it starts with recycled plastic resins or whether it starts with different kinds of feedstocks, we're doing a lot in that space.
Is it practical, Jim, to imagine getting back to virgin material? Some of these complicated polymers are difficult to get down to monomers, right? Do you see that as a possibility down the road?
I think it is. Look, it may not be a 100% yield result. In every process, there's always a little bit of waste. But I think we're showing ourselves that we can have pretty high yields today. And then as we move up the learning curve, we'll be able to improve on that. And as we design products for circularity, sometimes the things that cause recycling to be difficult are additives and other things that go in to the making of a package. If we can make the package without as much of those materials, that will make them easier to recycle. That'll mean less impurities in the recycle stream. So it's a lot of work, but from a chemistry perspective and from a process technology perspective, I think we can do it.
It all sounds energy intensive and expensive, frankly. And plastics, one of the wonderful things about plastics is they're very inexpensive and they deliver on their promise without a lot of cost. So as you look at it as a business decision purely, do you see the business case closing on a fully circular plastics economy?
Well, I think everything that we do is an energy equation. Whether we're talking about electric vehicles, it's where does the energy get used instead of burning fuels in the vehicle? You use a lot of energy to make battery cells and other things to make the vehicle, and then your energy changes to an electricity source. People forget that electricity is not a direct energy source; it's an indirect product. So you have to draw the circle right around the life cycle assessment to really look at the energy impact. If we move down this path and our answer is that we're going to try to electrify everything in the world, we're going to dramatically increase the electricity demand in the world at the same time that we're saying don't burn coal, don't burn natural gas, shut down all the nuclear plants. And look, solar and wind won't be able to keep up with all of it. So everything's an energy equation, and that's where the costs and the trade-offs come in. Having said that, I believe what the answer is to solve the equation for lower CO2 emissions. And this is what we need to think about is we're trying to solve, trying to create the perfect world. What we're trying to do is do what we do with less CO2 emissions. And if we make that the parameter we're trying to solve for and do that in the most cost-effective way, that really opens up more avenues for us. And so as we think about things like to talk about a hydrogen economy, to talk about more solar and wind, the role that natural gas will play, the role that new nuclear will play. If you want to take an energy intensive industry like steel, which needs electric arc furnaces, or let's say we can get to the point where we could make an ethylene production facility using an electric furnace instead of a natural gas furnace, you'll need efficient sources of electricity to be able to do that. And they have to be high intensity, 24/7, non-interruptible. And you say, I want to do all that with the lowest CO2 emissions possible. You've really changed the parameters. And I think you turn the research and the innovators into that, and you get your policies right so that you can tap the capital markets and get them energized to make those investments and get out of the way. This will happen.
Will it happen in the absence of any regulatory push one way or another? In other words, in order to kickstart some of these new ideas, does the playing field need to be leveled vis-a-vis the existing infrastructure by some way of fixing a price on carbon, for example?
Well, you'll have to have policy. I don't think there's any way you get to it without policy. The one thing you have to be eyes wide open about is that everybody in the world needs to follow that price on carbon. So there needs to be a market related price on carbon, and it needs to be recognized by everybody in the world. And if we do that, that will pull us all together to solving a climate problem. If we don't do that, if the United States alone puts a price on carbon and the European Union alone puts a price on carbon, all they'll do is push their industry out and push it into countries that aren't going to play by those rules. So I think that's one of the most important regulatory challenges that we have, is to get agreement. We've got agreement, broad global agreement on the need to bring down CO2 emissions. Now let's get broad global agreement on the need for a market-related price on carbon and the ability to trade that. And then that will allow us to move to the next step.
Big problems are what precipitate big solutions, big innovation. And it's hard to think of a bigger problem than the one we've just begun to lay out here. Help us understand how you, as part of the culture of your company, instill that entrepreneurial and innovative spirit. A lot of times it's hard for big companies to do that.
I think you have to put a challenge out in front of your people and give them some space and some room to work on it. And so today, if you looked at, we just talked about making plastics and making ethylene. Today we have 4 to 6 different avenues going on how we could come up with a different process to make ethylene versus today's energy intensive process and reduce the CO2 emissions 25, 50%. Maybe if we can also use carbon capture and sequestration, maybe be able to develop a zero carbon emission ethylene facility. That would be a giant leap forward for the chemical industry. So we've set that challenge out there for everybody. And in different parts of the world where there are different options, we're working on different things today. To set the challenge out there for the plastics organization to say by 2035, 100% of everything we make is going to be fully recyclable. Boy, that's a big challenge. I know in our Dow Mobility Science group, we have a team that's thinking about designing the circular car. That's something that isn't really getting a lot of discussion today, but you've got to be thinking about that. We have processes for you sleep on a mattress at home at more than likely is polyurethane. How do you capture that material and recycle that and give it another life as the same product instead of that going to a landfill? We've got a process ongoing to do that. So I think it's liberating. What you want to try to do is not try to constrain everything so much that you kill the innovation. So if I were to say to my team, I want you to reach circularity, I want you to reach low CO2 emissions. Oh, but by the way, you can't use these 10 good technologies. That's where we have to be careful with policy, is to say, I want you to get to low CO2 emissions, but you can only use wind and solar. That's a bad equation because many industries won't be able to solve for that equation. But if you open up, and all of the above energy policy and give them some room, I think they'll be able to make huge leaps forward.
When we think about Thomas Edison and we think of how he innovated, in many respects, he invented the modern day research and development team, right? He marshaled a team of very smart people and came up with many of his inventions. U.S. industry in recent years has had a difficult time maintaining a nice piece of R&D money because of the pressures of quarterly earnings and so forth. The days of, Xerox PARC or Bell Labs, that kind of expenditure are behind us, I think. How do you make the case to your board of directors and your stockholders to continue investing, in basic research R&D that might have a long lead time beyond the quarterly earnings report?
I think the best way is to talk about what you're trying to do with your customers. If everything that we did at work was trying to make the same existing product that we make today and just make it cheaper, That's not progress. That is a death spiral. What you have to do, every customer that comes to us, almost every development project that we have today has some element of sustainability in it. They're trying to solve a problem that's bigger than they can solve on their own, and that takes research and development. We're doing it differently today than we did in the past. Digital has had a big impact on what we do. So if you think about 20 years ago, if we were going to do a comprehensive research product, it would be many people in the labs, but we've got 20 plus years of digital experimentation and lots of data. And so today, if we want to design a new package or design a new polymer, before we ever go into the lab, the first thing we do is crunch data, just like we saw with COVID. Before we ever made a lot of vaccines, we crunched a lot of data to be able to really accelerate that path. And it isn't free. You have to invest in the digital part of the machine. You have to invest in your equipment, and you have to invest in your people. So R&D isn't a choice. Innovation isn't a choice. That's how a business grows, and you have to invest in it. And I think we don't, of course, you need to deliver results for your shareholders. You need to show them that you're a good investment. But I don't think justifying every single R&D project is necessary, because you've got to run a business and you've got to grow it over time, and you've got to respond to your customers' demands.
Edison, of course, was famous for saying he never failed. He just found, maybe 1,000 ways not to do things. And it's important to give your people in a large organization such as Dow the license to take risks, the license to fail. How do you communicate that?
When we see things aren't going to make it, we try to make sure we stop early and we move on. We know there's not one single right answer for that, and we don't punish people for failed experiments. We want to encourage them to move on to something that's going to be successful. So you've got to be quick at identifying it. We try to measure our success rate, obviously, to focus on the positive. We try to do a lot of the digital work that I mentioned before, really to screen out what could be failed experiments before digitalization and miniaturization of a lot of the experiments that we do. Success rates were low, but now you've got success rates in research of 70% plus. And so you have a pretty good line to commercialization. And I think we just saw that demonstrated in COVID with the vaccine development, is fast track high success rates. And the pharma industry uses the same technology that we use for high speed throughput research. And so I'm optimistic that we can get there. The other culture that we have to have is we have to be open-minded and be inclusive in thought, whether that's within our own company, but reaching out to other partners. We're in Midland, Michigan. The world doesn't come through here every day. We've got to be connected to what's going on everywhere in the world and open to ideas that have been implemented in other industries, and adopt those quickly and move. And I think that's part of being customer centric and part of being aware of what's going on in the world.
Does diversity lead to innovation?
No doubt about it. I mean, we bookended the ambition. Our ambition when we spun out of Dow DuPont was to be the most innovative, customer-centric, inclusive, and sustainable material science company in the world. And we bookended it with innovation and sustainability, because those two go hand in hand. And without innovation, your business is going to struggle. There's just a limit to how much you can be low cost. But customer centricity and inclusiveness really get to diversity, open-mindedness, awareness, collaboration, connecting with each other. And they're part and parcel of that journey. And I chose those 4 pillars of the ambition because they're intertwined. I don't know how you are innovative if you're not inclusive and open-minded. And you can't have a diverse organization if you're closed-minded and you're not inclusive. So it's not an easy mix, and they're not independent of each other.
Your company has been recognized with several innovations by the Edison Awards team. That must make you give you some pride. And just a couple of thoughts on that recognition and how important it is to be recognized in this manner by your peers.
We love to solve problems, and I don't think there's anything better than the recognitions we get, like the Edison Awards, and then to see them commercialized. Just within this past week here, Ralph Lauren just launched their Color on Demand platform, and this was a 2019 Edison Silver Award winner. And it was powered by Dow EcoFast Pure technology. So that's a technology where you treat a textile, and that allows you to be able to dye it different colors and cut the water use by 40% and the waste use. And Ralph Lauren, in the partnership with them, they aim to basically be able to do textile cotton dyeing with zero wastewater in the process. Wow, that's a huge goal. But look, textile dyeing is one of the highest wastewater generating process applications. So that's a big breakthrough. It may not seem like much to everybody else, but that's a huge breakthrough in our industry. And these Edison Awards are a reflection of some of the big challenges that our team works on. And there's a huge source of pride in our team in being, one of the most recognized, if not the most recognized, over this last 10 years in this space. And look, we're going to continue to try to deliver big innovations that can be used across a broad number of applications. That's what it's all about.
Well, I think the pandemic has proved science can save us if we put our minds to it.
We shouldn't be afraid of science. We should work with science. And I think it's also proven to us that there's a need for more scientific education, and there's a need to better communicate what we do. I think a lot of missteps that we had during COVID could have been solved by better communication and better education along the way. But there is no doubt we're making huge progress, and science is going to take us to that zero carbon world.
Thank you very much for your time. We appreciate it, and keep up the good work.
Thank you, Miles. Very nice to be with you, and thanks for having us.